We are taking class 12th Computer Science C++. This is unit number 1, which is the object-oriented programming in C++. C++ is an object-oriented programming language. We are taking the first edition, that is the chapter 1, the revision tour of class 11th. Whatever we have learned in class 11, we'll try to revise it so that we can get on to the advanced things in C++. Keywords. What are the keywords? See, a programming language always have certain words which is known to the compiler. These are reserved for them. So keywords are nothing but the reserved words that has a special meaning that conveys to the compiler. A compiler understand these by certain way. So these are the reserved words for special purpose doing something, and it should not be used as an identifier name. For example, if. You can use if, right? But since if is a keyword, you cannot use it. You will be tempted to use keywords like this, do, but these are keywords. Identifiers. So these identifiers are the names which you give, because you are going to use variables, the function names, the arrays, the objects in the classes, so there will be various names. For that, you need to have certain way to identify them, and identifiers does exactly the same. So it may contain the digits, letters and underscore, but it must begin with a letter or an underscore. You cannot start it with any number or a numeral. C++ is case sensitive. That means if you write uppercase, it will be very different from the lowercase. So a keyword cannot be used as an identifier as we just indicated. So there are certain valid identifiers which I can discuss, which is this PEN time 580. All these are valid because it is starting from the underscore. They are using alphanumeric, but they are not starting from the number. They should not start from number. This is the only rule which needs to be understood. The data types in C++. Data types are what? For any data, what kind of space you will need in the memory, and there are certain operations which can be tried upon or operated upon the number of variables and identifiers. So data types in C++ are basically of two types. First is your built-in data types. We also call it as a fundamental data types. So these data types are already known to the compiler. Compiler is aware of these data types, and these are not composed of any other data types. So we have certain fundamental data types in C++, like the int, integer, for integer data type. For characters we have char, for floating point numbers we have float, double we have double data type. And the data type also can be modified depending upon the size which you would like to use. So data type modifiers, there are different modifiers which you can employ in C++, and this is signed, unsigned, long and short. So in order to modify the size so that you can fit in certain situation, a signed, unsigned, long, short can be used. Variables. Now, any memory location in memory is identified by a certain name. So a name memory location is exactly, the content of that name can change. Say if I say this memory location is named as, say, my variable, okay, and my v. Now the value is not 2, it can be changed to 3. So that is why we call it as a variable. The name has come up from vary, so it can vary. So variable is essentially an identifier only that will denote a storage location which contains, or you can say the contents can be changed or varied during the program execution. And what are the declarations of a variable, how you're going to declare the variable? So the syntax is quite easy. You have to first give the data type, then followed by the variable name. Number of variables you can give, so there is no limitation. Just separate them by comma and end them with their semicolon. You can also initialize a variable while you are declaring it using this. Data type should be here, then this should be the variable name, and you can use this equality operator, and then the value can be assigned. So in C++, these declaration and initialization, it can be done simultaneously, right? Where the place is you are going to use for the first time, which was not possible in C language, the language which was prior to C++, and this is known as dynamic initialization. For example, this is float average. Now this average, you are saying sum by count. So the above two statements, these two can be combined like this: float avg is equal to sum by count. This you can easily use. Now coming to constants, a name memory location which contains or you can say the contents cannot be changed in the program execution is called the constant, because the things cannot be changed, the contents cannot be changed. So a constant is again an identifier which is showing you a memory location which is pointing to or naming a storage location, but the contents cannot be verified. So if you have two, you have name as my variable, and if it is given as constant, const in front of it, you cannot change the content. The compiler will indicate an error. So the syntax for constant declaration is quite easy. You just have to use this const, then followed by the data types, then the constant name with the equality sign to the value. This is an example, const float pi. You don't want to change the pi value in your program, so 3.14f, this you can give. Then we have a conditional operator. When we will talk about the different conditional operators, you can say the control structure, you will be able to understand it better. Why? Because this is a short form of if and else only. So for now, the conditional operator, this one is question mark and then colon, and we have content here like this. This is also known as a ternary operator. So it requires three operands. The general form is quite simple. This is the expression. If this expression is true, it will give you, because this is a logical expression, it is going to give you either true or false. So if this expression is true, this expression will be executed. Otherwise, this expression will be executed. You can also assign it to some value. That is, if you say a less than b, so if a is less than b, a will be assigned to min. Otherwise, b will be assigned to min. So if expression this a less than b is true, the value of a will be assigned. Otherwise, b will be assigned. So this is a simple conditional operator. You can write this if else in one line. Then we have type conversion. Say you have various data type. Now you want to deal in your program, in the course of your program, you might want to change your float to double to integer like this, right? So for that, what you are going to use, you are going to use, and compiler will also do something. So the process of converting one predefined data type into some other predefined data type is known as type conversion. So C++ provides us with two forms of conversion, which is the implicit data type or implicit type conversion and explicit type conversion. So what is the implicit type conversion? See, you don't have to intervene. Without your intervention, means programmer's intervention, this implicit type conversion is there. So whenever we have intermix of various data types in an expression, this kind of implicit type conversion takes place. So the C++ compiler converts all the operands into the largest data type operand. Please understand, if you have integer, you have float, and say you have a double in an expression, all these kind of data type variables are there. So all these will be converted to doubles. So the highest promotion will be there. Then we have explicit type conversion. In this explicit type conversion, the user defined, because it is user defined. So you will force certain data type to be changed by yourself. Then typecasting, the explicit type conversion of an operand is done by the typecasting method. How this is done? What you have to do, this typecasting operator, you have this typecasting operator. This will allow you to convert a data item into another data type item. For that, the expression or the identifier must be preceded by the name of the desired data type enclosed in a parenthesis. So it should be inside a parenthesis, which is actually the round brackets. You can say parenthesis and round brackets are similar. So this is your expression. You want to implicitly change it to certain data type, so that data type has to come, as a prefix or prior to this expression in the parenthesis this. So I'll give an example. The data type, you see, this is x plus y by 2, and whatever the result is, you want to convert, say x and y are integers, say. Then you want to change forcefully the content here to float. For that, you just have to write float inside the parenthesis in front of this x plus y by 2. There are some important syntax in C++ that will come across. That is if statement. So that is, if means if something happens, then what to do, and if something doesn't happen, then what to do. So both ways. If it is yes, where to go. If it is no, so certain ways there, some certain condition is there. So I write condition. If it is yes or if it is no, where we have to go. If it is yes, that is if this condition inside is true, we execute all these expressions or all these you can say statements. Otherwise, if this fails, else you go with these statements. So these are the what I'm trying to explain here is, you can write one statement. You don't need to use these round brackets. If you have more than one statement, you need to use this not round bracket, but these are curly braces. And in the case this condition fails, it is not true, then you come to, or the compiler will transfer its control to the else one, right? So this if by itself is complete. You don't need to use else. You need else only when you want something to be done when the condition fails also. Then we have if else if ladder. That means if certain condition is met, it is okay. If it doesn't meet, then you want to check for another condition. And if these two conditions doesn't meet, you want to check for certain other condition. For that, you use if else if ladder. For that, you just write else if. That is, you take if and else. If else construct will be something similar to what we have learned about if else. But because if checks for something, and if it fails, it checks for something. But here we want to check for some other condition also. For that we use else if. That is the condition 2. Likewise we go. And finally you can have else, or you can not have else. This is optional. Then we have a switch statement. We can say this is a more elegant and faster way to implement your if else or else if ladder. How to do this? You say switch, then you have expression of variable. This expression should give you only integer or a character value. This switch will only work for integer or character value. It will not work for double or float. For that, if this matches with certain case, so we have different cases. Actually, this is called a switch case construct. So if you have certain variable, or this amounts to certain variable or character, you have the various values inside your case. This is case this, this is case this, and which case does it match, that will be executed. And we have a break for this. If say, for example, we have a value 2 here, and this after this case we have a 2 here. So this will match and this will be executed, and then we break and we come out. If no condition meets, then you can have a default, or you can have an optional default. Now the for loop. This for loop is a very elegant loop. The reason is that the initialization, the condition where the loop is going to come out, and the update expression, that is the increment and decrement, you will find it in one line. This is the entry control loop, and all the content, that is the statement, are written in these braces. Then we have while loop. While loop again is the entry control loop, and we have the loop condition here, loop body. This initialization has to be written above this while loop, and the update has to be done somewhere inside. Do while loop. Do while loop, unlike the for and while loop, though do while loop is exactly similar to for and while, but just one difference, that this loop is the exit control loop. That is, the condition is checked after once, at least once, the do while has taken place. So loop condition is here. So do, then while, inside this brace you write your statements here. Break statement. And one more important thing is, when we are dealing with the loop constructs or control structures, we need to come out. Means looping is done again and again, iteration is done again and again, but at some point we need to come out, or at some point we don't want that loop to run. For that we have this break statement and continue statement. This break statement, it will enable us as a programmer to skip over a part of the code. So a break statement, the innermost loop is broken. That is, you come out of the innermost loop. That break, if it is enclosed in, say, while, do while, or say in switch statement, and the execution resumes at this statement, which is exactly or immediately following the body of the terminated statement. That is, once you come out of the loop, the next statement after the loop is going to be executed. For example, this is the working of break statement. We have a while statement here, and in this while statement we are testing something. This is a statement. So here, if the value is greater than 2000, then we break. And if we break, it will not go to any other statement after this. It will go to the statement which is after this closing brace. Similarly, when we say break, this is the for loop example. We have all the initialization and expression, and then update and this checking. So this is a statement, this is going to run if now we are checking the same condition with a break. If this condition is true, then we are going to come out, and this statement is nothing but the statement which is after this brace. Similarly, with do while, exactly similar way we are going to run it. Then the continue statement. See, you want to run the loop from 1 to 10, but you don't want to do anything for 2 or say 7. So this loop is going to run from 1 to 10. How to skip the execution for 2 and 7? For that we use the continue statement. So the continue is going to jump, or this is again a kind of jump statement. This is just like break statement, but this break statement is going to skip, or it is going to take you out of the loop. But continue will not take you out of the loop, but it will continue the iterations or the looping. Only that part at which this continue is applied will not be executed, or anything which is after that continue will not be executed. So we don't need the termination. For that we need break. But if you just want to go to the next iteration, we use the continue statement. So this is the example of the continue statement. We have a while here, and this is a statement. This is a if condition. So if condition is true, and if we go to continue, we just don't go to this condition or this statement. We go to the next iteration. We don't come out of the loop. I hope you got the idea. This is same for and do, that if this condition is true, we continue. That means we just skip the part after, or anything which is after continue and before braces, we just skip them and again go back to the next iteration. Similar with the do while operation. So this is the first part of the revision tour of C++ of class 11th. We'll be taking one more. Till then, thank you so much and take care of yourself. We are looking at the revision tour of class 11th for the C++. Functions. Function is nothing but statements, a group of statements that is going to perform certain action, and performing certain action and also returning some value, may not return some value, but it will perform some of the other action. So we have built-in function, that is the library functions. So these are already there in C++ in the header files, and we can directly use these functions. We don't have to give their definition because the definitions are already built in. That is, you will find it in the library functions like the sqrt, like the toUpper, like the isDigit. So these are some header files, some of the other files and functions which we generally use. Like in stdio.h, you find getAs, putAs, ctype.h. This is a character type function. This is for string related function. This is a math and standard library like randomize, random. So for string we have strcpy, strupr like this. Mathematical you have absolute, value, square root and cos, sine, all these. For C type, to lower, isDigit checking can be done. So randomize, what this function does, this function will give you a seed value, okay, and also an algorithm in order to help the random function to generate the random numbers. So this seed value, it can be taken from the system, current system time also. So for this randomize, as we said, that this function is providing the seed value and also the algorithm to help the random function to generate random number. So this is a random. Inside this function helps an integer parameter, say it is an x, and generates a random number between 0 to x minus 1. Please understand, 0 to x minus 1. That means if you have a random and you have inside it 7, this is going to generate between 0 to 6. 0 to 6. And in order to generate the random number between say lower and upper limit, what you can do is you can use the formula called random. This is upper limit, this is lower limit. So u minus l plus 1 plus n. This u is the upper limit, l is the lower limit values, in between which we need to find out the random values. For instance, if you want to find random numbers, say between 10 to 100. So what we need to write in this, we need to write random. This is u, that is 100 we are going to take, L we are going to take 10, then plus 1 and L again 10. So this will generate random number between 10 and 100. Then we have user defined function, that is the function which we or you have to define, or we have to make by ourselves. The function which are user defined, that is we are going to define it for certain purpose, for performing some functionality. For using this user defined function, first we need to define it, then we have to use it. That is, we have to give the proper functionality or the code inside that function, and then we use it. So declaration of the user defined function is something like this. This is the function name, and prefixing it is the return type, and after this, following it in the parentheses are the list of formal parameters. Inside this, you will have body of the function. That is simply the statements, nothing else. Then how to call a function? Whenever we call a function, we have to provide actual parameters. That is, we are trying to send the actual parameters that should match the formal parameter which you have given in the prototype, or you can say the formal parameter list in number, type and arguments. So number, type, arguments of the formal parameter should match the actual parameters. I'll show you. I'll tell you what formal and actuals are. These are the formal parameters. If this is a function, say you have made a function addition, this is the return type, and these are the formal, this A and B, these are the formal parameters. Now this is the formal parameters, and when you're passing 5 to A and 3 to B, these are your actual parameters. These are your actual parameters. So you're passing the actual parameters here, and when we add it, so simply whatever you have written, the result will be returned to Z, and you can now print or use Z. So here also this Z will get the 5 plus 3, that is 8, because this is addition. Now this function has to be written by ourselves. So we have the function name, then we have list of actual parameters. This is the simple syntax as similar to the library function. So just take a program. We have hash include iostream.h. This is our function addition, and this is the return type, and these are the parameters. Now we are trying to give the definition of the function. So a, b, and we say we have taken a temporary variable r, and we are adding a and b and providing it to r, and we are returning it. So this integer before addition is actually signifying that you are returning a r, that is the addition result of a and b. So when we come inside main, we take z, any arbitrary z, and this function has to be given like this: addition 5, 3, that is you are passing the actual parameters. These are the actual parameters for these formal parameters. So z will give you a result, and this z can be printed anytime. The result is 8. Now there are two things: call by value, call by reference. Now you have say x equal to 3. Now you say x plus plus, right, in the function. This 3 will become 4, but you don't want this x to become 4. So for that, means original value you don't want to change. For that, you use call by value. But if x equal to 3 and you say x plus plus, x has to become 4. You want the actual value to be changed, which is being passed. For that, we use call by reference. So call by value, in the call by value, we pass the arguments to a function. It will just copy the value of actual parameters to the formal parameters. So they are just copying the value of the actual parameters to the formal parameters. That is, it will create, the argument will create its own copy. So any change, any modification that has been done to the actual parameters will not be reflected, right? And in the case of the above program, that is the addition program we have just seen, is an example of call by value. But now, this call by reference is having a different mechanism. So you want to change the actual value. For that, we don't pass the value, but we pass the reference. That is, this is the memory location, x is there. So we don't pass x. We pass ampersand of x, that is the address of x. That is, we pass the reference of x. So whatever is inside this, we pass the reference and then change. If it is changed to 4, so the actual value will be changed. That is, in call by reference method, the call function do not create its own copy of original values, as you see here. It will not create its copy. It refers to the original value only by different names, like the reference, as I just said, ampersand x. So the call function works on the original data, and any change which is being done is reflected here, and unlike the case in the call by value. So this is the example of passing parameters by reference. You see, this is a main. We are trying to pass 1, 3 and 7. We are trying to print it, but here is a function called duplicate. Let us see what is going on in duplicate. In duplicate, it is not returning anything, but the x is given here, but as ampersand receives it, that means you are passing the ampersand or the address of 1. So now you are changing it or multiplying the value with 2. A star, this means A is equal to A into star, A into 2. So what you are trying to do, this will be equal to 1 into 2. So you will get 2 here. X will be 2. So actually x was like this. X has a position, 1 was there. Now you pass the reference of x, that is ampersand x. So reference of x. Now A is a reference, actually A and x can be referred as the same name. Now when you pass 1 or 3 or 7, when you have a location here and 1 is there, and you are changing, you are multiplying x with 2. So this value will become 2, and when you print x, x is now having value 2. So the ampersand, this is address of operator, is specified that the corresponding arguments are to be passed by reference, not by value. So this is how it is done. So this duplicate x, this is the actual parameter, is goes to this point, y goes to this, b, and z goes to c. Constant arguments. In C++, we have constant argument. This constant argument means we don't want this argument to be changed. So in order to make a argument constant, we just have to add one keyword, that is const. This const, it signifies that this function will have certain values inside it as an argument, and it is constant, so you cannot change it. This qualifier const will tell the compiler that the function should not modify the argument in any case. Otherwise, the compiler is going to give you an error. It will generate an error when this condition, if you happen to violate it. Default argument. Now, say in a banking system, the interests generally don't change for quite some time. So why to give again and again or pass this interest rate? Rather, we can just have a default value of that. So here you just see an example. We have a function called interest. We have principal in time. But in this rate, we are fixing it. We are saying float rate is equal to 0.70f. So even when we call it this principal 5600, time is 4, but we are not giving any value, any third parameter. So automatically by default, the rate will be taken as 0.70 in the program. So C++ allow us to assign the default values to function parameters, which is very useful in case of matching argument, which is actually not passed in the function call statement. See, here we have not passed it at all. And if you pass it, that will overpower this 0.70. In case, if this would have been 5600, comma 4, comma say 0.6. So this 0.6 is going to overpower 0.70, right? So the default value are specified at the time of function definition, right? So this is how it is done. So the next one is formal parameters. So what is formal parameters? This formal parameters, what the in the definition, function definition, where you give the parameters which appear in the function definition, these are called the formal parameters. And when you are actually calling the function, at that point, those parameters are called as the actual parameters which are actually going to the function. And we can have a function with no return type. We use generally void for that, because the function can only perform printing, so it is not returning any value. So in this case, we should use the void type, and this is a special specifier void that indicates the absence of a type. Then we have a return statement. So return statement in a function, because function does some work and it gives you value. Say it is adding a plus b and it is returning some z. So this z is returning, so you have to return it back to the main function, because function is just a block of statement which does some work, so it has to return some value. So the execution of this return statement, after this the function will terminate, that is, it will exit, and the control is passed back to the calling function. In most of the cases it is main. So the transfer control back to the operating system, right? So this return statement also returns a value to the calling function. So it is returning the value. The result is returned, and the syntax is simply return and that value in the parenthesis. What is the scope of the identifier? See, the part of the program in which the identifier variable or the value can be accessed, okay, can be accessed is known as the scope. What is the scope of that identifier? So we have four kind of scope. That is the local scope. In the block, only in the braces, the identifier declared in a block is called the local, is the local to that block, and can be only used inside these braces, not outside this. The function scope, again the identifier declared in the outermost block of the function, and that is where the function starts. This has a function scope. Overall function and the content inside the function can use this whatever you have defined inside a function. While the file scope, that is the global scope, the identifier has file scope or a global scope if you define it outside all the blocks, okay, and it can be used in all the blocks and functions. Then we have a class scope. When we have a name of the class member, this has a class scope, and this is local to its class. So along with scope comes the lifetime. So what is the lifetime? This is the time duration, that is the time interval for which a particular identifier or a data value it lives in the memory. So the time it lives in the memory is the lifetime, right? Then we have arrays. So what are the arrays? Arrays are simply, what you can do here is, you can have, say, one variable for some name or you can say age of students in your class, but you have 50 students. So you can have 50 variable, or rather than having 50 variable, why not to have just one array name and we can have 50 positions here. So this array is just simply like this. You have an array name and this is the size. This size is simply 50 here. So this whole the array, or you can say the contiguous memory location one by one of 50 location is given by the array. So you have a data type, all integers, that is your age can be put in here, and you have an array name with size, and return type is data type. So not return type, but the type of the array is the data type. So I'll show you with an example. When we work with one-dimensional array, that is, this is only one dimension. So we have just one row, contiguous locations. So the general form of how to read, we have to put a loop for reading elements of the array, 1D array. For that, what we do, we start with 0, we go up to size -1, that is I less than size, right? So array always starts with 0 subscript and goes up to size -1. So if this as z is the size, it goes up to size -1. So we just see out, that is, you enter some enter array element. This is how to read, and you can just see in with array name with a subscript. So generally processing part may be included with the loop for reading or printing, or otherwise you can do another thing, that is a same type separate loop may be used for processing. So this is the general form of for loop for printing. Now this is for reading, this is for printing. So 0 to, again, size -1 we go, that is I less than size, and we just see out array, whatever is the array name with the subscript. How to declare the 2D array? Now 2D array, see, this is the array name, this is the number of rows and columns. So now you have, say, age of your class, and you want to have the age of other section also. So these are the rows and these are the columns. So these are the data array name with rows. These are the rows. So this is row 0, row 1, row 2 likewise, and this is the column 0, column 1, column 2, and likewise. So this goes up to r-1, and this goes up to r-1, and this goes up to c-1. So this r represents the number of rows, c represents the number of columns in the form of 2D array. So how to work with two-dimensional array? We have to use two loop. Why two loop? Because first we have to go to a row, that is one loop for the row, and then we have to go inside the column. So first is going to a row, then to the column. So this is a general form for reading loop for reading elements in a 2D array. We go from 0 to r, this is the row. We enter the first row, and then we go to that column 0 to c, and then we can just read from it. And if you want to print the element, this is how it is done. This is for going to the row 0 to r, and inside this we come to the each value of the column, and we print the names or whatever inside. Of course, the r and c are representing the number of rows and columns. How to define a structure? See, array cannot have multiple data type. So we have structure, and this structure is actually the basic building block of class, which is the heart of any object-oriented programming language. So here, when we define a structure, we use a keyword called struct. The name is yours, means you can give the name by yourself, and then we have different data types. So multiple data types can be given, and followed. This is inside a braces, and then we have a semicolon. So this is how to declare structure variable. You have a struct, name of structure, and different data types are there, and you have different data members here, and we have various variables. Now this structure, you have made a structure, and when we have made a variable, this variable will have access to all these members. So just if I want to access this member, say this is member 1, this is var1, I'll say var1.1. If I'm just naming data member 1 as 1. So this is how we access the members of the structure. So when we want to declare the structure type variable separately, that is after defining the structure, that is structure name, then variable 1, variable 2, variable till n. So this can be defined in this way also. So these both are similar. How to access the structure element? As I just suggested, dot operator. So in order to access the structure element, we use the dot operator. So this is just denoted by dot, And the general form of accessing the structure element is simply the structure variable name, you can say, with dot of element name. Then we come to the pointer. Now pointer is nothing but a variable which holds only the address. So it is normal variable, can have 1, 2, A, B, C, D, that is string. It can have number, it can have floating values, and pointers can only hold the address of these values. So pointer is actually a variable that will hold the memory address of another variable of some type. If you say integer pointer, then it will hold the address of the integer variable. So how to declare and initialize the pointers? So syntax is quite easy. You have to say data type, you have to use a star here, and variable name. So int star p, now this is a pointer p which is holding the address, which is able to hold the address of an integer variable. This p1 will hold the address of say the float variable character. This c will hold the address of character. So how to do it? See, this int a is 10. Now this is a pointer p, so p will hold the address. Ampersand a will get you the address, will take out the address of a, and it will assign it to p, and p is able to hold the address of this variable. Then there are certain pointer arithmetic we need to know. Pointer arithmetic. Pointers are what? Pointers are keeping the address of certain variable, right? So two arithmetic operations, addition and subtraction, this can be performed on pointers, but you add 1 to pointer, that doesn't mean that you are actually adding the numeric 1. You are actually incrementing to the next or going to the next memory location. So you are actually adding the size of whatever the pointer is pointing at, maybe integer, say 2 bytes or 4 bytes. So it will add to that. Each time a pointer you increment, it will point to the memory location which is of the next element of the same type, like that is the base type. So if we have a pointer, say int p, this is a pointer, and you say p plus plus, that means you are incrementing this p, pointer. So if the current address of say pointer is 1000, and just assume that integer is taking 2 bytes, so it will go to 1002, that is the p will increase to or increment to 1002 rather than 1001. So when we add 1 to a pointer, it actually adds the size of the pointer's base type. So what is the base address? Always understand that the pointer holds the address of very first memory location of array where it is pointing to. So if we have an array can have different sizes. So the first element, this is the first element of the array. The base address is actually a pointer. The pointer is holding the address of this element. So address of the first memory location of the array, this is known as the base address. How about dynamic allocation operators? So C++ have dynamic allocation. So C++ dynamic allocation operates or operators. It allocates memory from the free store, that is heap. So heap is, there are various areas like the heap, like the stacks. So the dynamic allocation operators take out the memory from the heap pool and allocate to whichever operator or whichever allocation is required. So the pool of the unallocated heap memory provided to the program, this pool is available for us. So C++ define two operators, which is the new and the delete. So these are two operators we have, the new and the delete we have. So if you correspond it to C, you will see malloc and free. So this new and delete that performs the task of allocating and freeing the memory during the runtime. Then pointers and array. As I said, C++ treats the name of the array. Only you have to give the name of the array, that will be only the pointer. So this is the pointer which is pointing to the base address, that is the address of the first memory location of the array. Typedef. Typedef is for type definition. So this typedef keyword, it will allow to create aliases, means these different name for the same thing for data types. So the syntax would be something like this: type def, you have the existing data type, now you have given the new name. So type def int num means now wherever you use num, it will correspond to int only. Hash define preprocessor directive. So this hash is very important. Before going to processing, there is certain pre-processing is going on, that is, things are being placed inside your code. So this hash defined directive, it creates symbolic constants actually, those represents this representing as macros. So now we have macros. So what are these macros? Macros are nothing but the preprocessor directive. So it starts with hash and it is created using hash, right? So this define that it serves as a symbolic constant. They are created just to reduce the amount of repetitive coding. The way you do or write functions, it's something like this with some differences. The differences are in the way they are executed. So there are various macros, not only functions, not only the way function it resembles, but also say hash define pi 3.14. So pi is what? This is a macro, and it will replace 3.14 throughout the program. Wherever it finds pi, capital Pi, it will replace the 3.14. Then we also have something resembling the function. So hash define max a comma b, a greater than b, question mark a colon b. So this defines the macro, which is called the max, and it takes two arguments, a and b. So this macro may be called like any other function. So just as an example, if you pre-process it, say max x comma y, the a will give you number which is, if a is greater than b, then if this a is greater than b, then a will be assigned to a, capital A, otherwise b will be assigned to capital B. So this is simply a is equal to x greater than y, question mark x colon y. And as I'm just saying that we will just understand that macros, the content is placed inside your code. So this is just this code, this from here to here being put in here. Okay. Function overloading. So this function overloading is the process of defining and using functions having the same name. It may have different argument layers, it may have different return types. These functions, they are differentiated during the calling process by the number of arguments, the order of the arguments, and the types of arguments which is passed to these functions. For example, see, all these functions, three functions have the same name, but the type it has are different. Means this one has integer, the other has double, the return type is also different. So